Hello everyone and welcome back to the channel. This is the third video in the heart series, and in this one we're talking about the internal structures of the heart. So here I have the right view, which is also known as the atrial face of the heart. And to help situate us a little bit better, I'm going to first point out a couple things. Here we have the right the right atrium and the right ventricle. Similarly, on the left side, we have the left ventricle and the left atrium. Great. So, just a quick background of really where the blood is coming from before it re-enters the heart. We have the blood going through systemic circulation, the muscles, the organ systems, they're taking the nutrients and the oxygen that they need, and the blood is going to make its way back to the heart, and it's going to enter into the right atrium, okay? And the right side of the heart in general. And how it does this is it's going to come through this major vein known as the Vena Cava. And this Vena Cava has two parts, the cranial and the caudal Vena Cava, that are going to merge together and form this little tuberculum, or this intravenous tubercle right here. Great. And on this side, we have the cranial Vena Cava and the caudal Vena Cava right over here. Perfect. And the ridge that they form when they merge, it's going to propel and push the blood downwards into this little opening near the right atrium. Let me zoom in, it might make it a little easier as we draw more structures in here. So now that we kind of have the basics, I'm going to get rid of some of this and clear up the image. So drawing this in blue, what we have now is the sinus of the Vena Cava. This is the first part this deoxygenated blood is going to enter after it makes its way back into the heart and towards the right atrium. So this sinus of the Vena Cava is important because it's this point where we're collecting the Vena Cava, where we're collecting the deoxygenated blood. And it's not only the point where the blood from systemic circulation enters into the right atrium, but it's also this point where we have other structures entering into the sinus and providing this deoxygenated blood. One of them is this coronary vein of the heart that's basically providing the rich oxygenated blood to the heart itself. And this is going to drain and empty into this coronary sinus. Into the coronary sinus, which is also going to be connected then into the sinus of the Vena Cava. So this is entering into the sinus. We also have, I'll do this one in green, a little fibrous impression or depression, I guess you could say, in the tissue of the heart. This is called the Fossa Ovalis. And Fossa Ovalis is, let's put this, I'll just draw it in here. The Fossa Ovalis is a little fibrous wall, you could say, that is separating the right from the left atrium. But what's important is when we're early on in development, there isn't necessarily a need to separate the deoxygenated and oxygenated blood because a lot of the blood supply is coming from the mother. So there isn't really a big need to separate and make it efficient for the heart to separate the two types of blood. So this little depression is once open during development, and then as we are born and the body begins to become more efficient to utilize the oxygenated blood, they require this closing of the fossa ovalis, and this is done with fibrous tissue closing this little impression. On the other side of this little sinus region, we have, I'll draw it in yellow, these muscles. And these muscles, they're called Pectonati muscles or Pectinate muscles. And they're important because if you remember from one of the other videos, we talked about the auricular side of the heart, where we have the flaps of the heart. And these flaps of the heart are important because they hold muscles that are required required basically to contract and push the blood from the atrium into the ventricle. So these are the pectinate muscles of the heart in yellow. In order to push the blood from the atrium into the ventricle, we need to get through an opening. And this opening, and I'll try to draw it nicely, is controlled by three little flaps. Okay, and these flaps make up what's known as the tricuspid valve. Okay, this tricuspid valve is known as an atrioventricular valve because it's separating, or the passageway between the atrium and the ventricle. So the blood is going to enter into the sinus from the vena cava. The sinus is the collection point before the blood really enters into the entire atrium of the heart, which is like basically this whole region is now the atrium of the heart. And it's going to push from the atrium down into the ventricle. Now, the way it does this is that, yes, there's the pectinate muscles up here contracting and creating this pressure that's going to push the blood where there's, the less resistance, and it's going to go through this valve. But what allows this valve to open up is muscles in the ventricle that are going to be starting at the bottom and around the sides. But these muscles are going to be connected to these cords. And they're called chordae tendineae, however you like to pronounce it. These cords are basically going to be like ventriloquists for the valves. And they're going to connect these valves to the muscles. And when these muscles contract, they're going to pull on these valves and they're going to open the valves, allowing the blood from the atrium to now drain and enter into the ventricle. So these muscles, they have a name. They're papillary muscles. And we have a bunch of papillary muscles within the heart. These cords I mentioned, their Latin term is called chordae tendineae. And they're basically just fibrous cords that have some elastic tissue that are pulling on the valves of the ventricle. So now we have the blood entering into the right ventricle. There's a few other things to point out. Along the very bottom of the heart, there's going to be all this tissue that looks like it's really fleshy and rather soft compared to some of the other tissue, or really porous. And this is called basically it's another set of muscles, but they're the carnate muscles. And these carnate muscles are also involved in helping with contraction forces. Right here along the edge, this is going to be a wall that's separating this right ventricle from the left ventricle space. And basically, that's what we have in the right side of the heart. When we look at the left, there's a few differences, but in general, it's the same. What we have is in this case, we have, I'll draw it in blue, we have a bicuspid valve that's going to be on the left side of the ventricle. And this one only has two, as opposed to the right side that has three flaps controlling the valve. So this is the bicuspid valve, and it's also the atrioventricular valve. They will also have their own chordae coming down and connecting to papillary muscles at the bottom of the heart. And essentially, as the blood comes in, it's going to fill into the ventricle. The strong muscles and the trabecular muscles along the bottom of the heart and all basically surrounding the base and apex of the heart, we're going to have this muscle contract, and it's going to force the blood out from the ventricle space. And in both of these diagrams, we would have the blood, I'll draw it in green, it might be better, basically leaving the ventricle and entering their respective trunks that they're going to basically enter into. So from the left ventricle, we're going to go into, maybe I'll do this in red. So from the left ventricle, we're going to enter now into the aorta. It's going to go into the aorta, but in order for it to do this, it has to go through these little semilunar valves. And I'll just draw this here. Semilunar valve, and this valve, it's going to be the same on the right and the left side of the heart, because you'll see on the other side, we also have this oxygenated blood. Let's do this maybe in orange. It's going to be leaving from the right side of the heart, going to get oxygenated, and it's going to be going through the pulmonary trunk. And also this pulmonary trunk is going to have its own semilunar valve, and these are both the same type of valve. Perfect. So blood is going to leave, it's going to become oxygenated, it's going to become deoxygenated based on the systemic circulation and return back to the heart. This is not the prettiest diagram, but everything, the basics of everything is really there. I'm just thinking if there's anything else I really want to point out before I end this video. And really, I think we've covered everything in this one. So see you guys in the next video.